Bartlik channel for construction basic knowledge. It is about determining axially loaded column, uni-axial loaded column, and biaxial loaded column.
Welcome at Bartlik YouTube channel for more construction basic knowledge. And for those who haven't subscribed, that is for the viewers who haven't subscribed, please do so by pressing the subscription button such that when we upload a new construction basic knowledge video, YouTube will automatically notify you. Welcome. So today's video, we are going to do a video that is concerning about determining whether a column is an axially loaded column or if it is a uni-axially loaded column or a biaxial loaded column. Therefore, please, my viewers, enjoy the video. Welcome back again. So I am going to use an illustration. I'm going to use a column grid illustration or a column layout illustration, but this illustration is just a sketch that I've done using my freehand. So it is just for the purpose of making my viewers understand. So it's just a hand sketch, a column layout plan done using my freehand. But I hope the content will be actually understood well, regardless of the sketch. All right. So we will start by axially loaded column. How do we determine if a column is an axially loaded column? So an axially loaded column has got the following characteristics, or rather, these are some of the things that will make us know that a certain column is an axially loaded column. Therefore, using our sketch, so as you can see our sketch on the screen, this is the sketch that I've come up with. It is just a freehand sketch. Now, if you look at column 3B, and even before we identify column 3B, you can see I have the grids. I have grid 1, 2, 3, 4, that is horizontally, and I have grid A, B, C, D, that is vertically. So I have come up with the name of the column using the grids. So column 3B, it is a column that lies under grid 3 and grid B. That is grid 3 horizontally and grid B vertically. So column 3B, we will identify it as an axially loaded column. So an axially loaded column is also known as an internal column. And what are the features of an axially loaded column? The features of an axially loaded column, that is column 3B, is that beam on the all four sides will be uniform in length. So as you can see from our layout is that the beams on all the four sides of that column, they are equal in length. That is 4350. So the beams on all the four sides are equal in length. And then, therefore, the moment that will be generated, the moments that will be generated on that column will be equal on all four sides, since we have equal length of the beams. Therefore, the moments that will be generated on that column, they will be equal, that is on all four sides. Therefore, the moment generated is neglected because the moment will be balanced on four sides of the column. Therefore, column 3B is an axially loaded column. And you see the load is concentric. The load applied on that column is concentric. That is, it is acting at the center of the column. Alright, that is how we determine if a column is an axially loaded column. Let us go to the next, whereby we want to determine if a column is a uni-axially loaded column, or it is a uni-axially loaded column, or rather it is an axial loaded column with a uni-axial bending moments. But we can just say a uni-axially loaded column. So again, using our layout, using our illustration, our column layout, we can identify column 3C. Column 3C, that is column on grid 3, that is horizontally, and on grid C vertically. So column 3C, it is a uni-axially loaded column, whereby we say the loading is actually exerted on the column, but it undergoes a uni-axial bending moments. So we call that column a uni-axially loaded column. So the features of that column, or rather the things that will enable us to understand or to know if that column is a uni-axially loaded column, is that the two opposite sides of the beams are equal and the two others are unequal. So as you can see, the beams surrounding that column is that two opposite sides of the beams are equal and the other two opposite sides are unequal. So the beam on opposite two sides will be uniform in length and other two sides will be unequal in length. So you can see from our sketch, we have beams with the length of 4350, that is on the opposite sides. And then on the other opposite sides, we have beams of 4350 and the other one is 1700. So these opposite two beams of 4350 and 1700, they are unequal in length. But the other two opposite sides, which are 4350, 4350, they are equal in length. Therefore, the moment will be generated an equal axis side, whereby only axis with an equal beam length, that is where the moments will be generated. Because the other two opposite equal sides, those moments will counter each other. Therefore, that column is a uni-axially loaded column. Therefore, the loading is not concentric. The loading exerted on that column is not acting at the center of the column. So it is eccentric. The loading is eccentric. It is not concentric. And then another one, or the last one, if we want to determine whether a column is a biaxially loaded column. If we want to determine whether a column is a biaxial loaded column. So again, we go back to our sketch. We go back to our column layout sketch. We can identify column 1A. That is column on grid 1 horizontally and on grid A vertically. So column 1A, it is a biaxial loaded column. Why do I say so? Now let us study this column. A biaxial loaded column, the beam on the adjacent two sides will be unequal in length. As you can see, it is a corner column. So a biaxial loaded column, it is also known as a corner column. And you can see the two adjacent beams, the lengths are not equal. From our sketch, that is column 1A, we have a beam of 7 point something meters, and on another side we have 4350. So those two adjacent beams, they are unequal in length. Therefore, it is a biaxial loaded column. How do the moments act on this column? The moment will be generated both on x-axis and on y-axis. The moments will be generated both on x-axis and on y-axis. Therefore, the column shall be designed for generated moment on both axes and axial load. So that is how we know that that column is a biaxial loaded column. So that is how we determine whether a column is an axially loaded column, a uniaxial loaded column, or a biaxial loaded column. I hope my viewers, you have enjoyed the video, and I hope you have understood what we mean by if someone says that a column is an axially loaded column, or it is a uniaxially loaded column, or it is a biaxially loaded column. So these things enable us when we are doing our structural design for the columns, because now the loadings will differ on these columns, the way the moments are acting on these columns. So that is how we determine whether those columns are an axially loaded column, or a uniaxial loaded column, or a biaxial loaded column. This is just for the initial stages of structural design for the columns. That is the RC columns. Thank you, and please continue to subscribe. Don't forget to share, like, and comment. We value your comments for the improvement of our videos. Thank you.